Welcome to another exercise for the workbook statistics, this time with an exercise on measures of distribution. Here as an exercise we have the height of donkeys in a children's zoo are distributed as follows. And we get this set of data. And our first task is calculate the average height and the uncorrected standard deviation. Well, we need this as input for part B, where we have to calculate the uncorrected skewness and kurtosis of the dataset and also interpret the results. Well, let's start with the first part. Here we have first the average or the mean. We simply add up all the different values and then divide them by the number of observations. So in total, if we check here, we have 9 observations. So we divide the sum by 9, giving us an average of 1.1 meters per donkey. That's the first part. Then we can calculate the variance for the second part. Here we can use the simplification of just squaring all these values and adding them up. Or, well, I see 1.05. I have this twice here, so it can just go 2 times 1.05 to the power of 2. So squaring all the values and just summarizing this a little bit more. Again, I divide, because this was the uncorrected version, I divide by the number of observations. So that's the first part. And then I subtract from all of this the squared mean, the squared average I just calculated in the first part, giving me here a value of 1.2206 for the first part and for the second part of 1.21. So in total I get for the variance 0.0106. This value needs to be positive or 0 because the variance is either 0 or a positive value. It can never be negative. So that's the first part. And well, for the variance, from the variance, I can simply take the square root, giving me the standard deviation. So square root of 0.0106 gives me a standard deviation of 0.103. That's actually the first 2 parts. Well, that's part 1 and also the first part, which I need for part B, where I want to calculate the kurtosis and, well, the skewness. And for both I need, as I just calculated, average and standard deviation. So I just copy them. For the skewness, my formula is simply the value I have in my data set minus the average, which I'm given up here, divided by the standard deviation, which I have here. I calculate this for all 9 observations, always taking this term to the power of 3, summing all of this up, dividing this by the number of observations. Well, if I'm doing this here, again, some of the values exist more than once. So I get, for the first part, this more or less standardized value of 1.9417. That's everything here in the brackets. And then to the power of 3. Doing this for the second part, third and fourth part, because there's only 4 different values in the data set. Adding all of this up, dividing this by 9 for the 9 observations, giving me a skewness of 1.3473, which is larger than 0. That's actually the important part here. To make a distinction in which direction the dataset is skewed, I need to know whether the skewness is positive or negative. Since it's positive, I know my distribution is rightwards skewed. Would have been negative, that would be leftward skewed. If it's 0, it would be symmetrical. Well, that's part 1. Part 2 is the kurtosis, and I do more or less the same as before. The only difference, do not take this to the power of 3, but to the power of 4. So while the skewness can be positive or negative, the kurtosis is either 0 or positive. Well, it looks similar to before. Instead of to power of 3, I'm going with power of 4. Adding all of this up, divide by 9. Get a kurtosis of 2.0855. Here the important value to remember is 3. Why 3? Because 3, that's a kurtosis of the normal distribution. So I'm always comparing, is my data set, well, more broader, more heterogeneous than the normal distribution, or more homogeneous, so a bit steeper than the normal distribution. Here, value is smaller than 3, so it's compared to the normal distribution, it's a bit more homogeneous. So we call this, that the distribution is so-called platykurtic distribution. It's a bit more closer to the mean. Well, that's then everything there is to this unit. So I hope you enjoyed it. I say goodbye and see you next time.